Hi guys, welcome back. This is Miss Bogut again. Today we're going to be talking about experimental probability. So go ahead and follow along with your notes. In experimental probability, the likelihood of an event is estimated by repeating an experiment many times and observing the number of times the event happens. That number is divided by the total number of trials. So to put this simply, and you guys have probably seen this formula before, but when we're talking about probability, experimental probability is defined as the number of times the event occurs over the total number of trials. So in any experiment, we can divide, say, the number of times we get heads when we're flipping a coin over the total number of times that we flipped the coin. That is how we get the experimental probability. Now, we can use this experimental probability to either make decisions or make predictions about what will happen with different numbers, things like that. So let's go ahead and try some examples. Our first example is after 1,000 draws of a bag from a bag of marbles, the following information was recorded. And then we have these different colors and how many times we do blue, red, and yellow. So let's go ahead and take a look at this first example. It says, from the information above about drawing marbles from a bag, estimate the probability of drawing a red marble. Well, as you know from our notes yesterday, we're always going to write down the probability and then the event. So for instance, here we're going to talk about the probability of getting a red marble. And we know that our formula is the total number that we recorded of red over the total number of trials. So we want the number that was red over the total draws. So we're just going to go ahead and fill that in. So here we had 267 marbles were red, and then up here we realized that it was 1,000 draws. So I don't really have to count. I could, just to make sure, I could add 448, 267, and 285, and I would come up with 1,000. Okay? Now, if I want a probability, yes, I can leave it like this, but that's not very helpful. So really I want a percentage or a very simplified fraction. Well, I know, and I'm going to do this in a different color, but I know that I can actually get my percent by moving to have the denominator be 100. That's what a percent is. So if I move my decimal place over once in the bottom, that gets me to 100 in the bottom. And remember that a percent is always out of 100. So I'm going to do the same thing to the top. So that means that this fraction, 267 over 1,000, is the same thing as 26.7 out of 100. So that gives me my percent. So this is a 26.7% chance that I'll draw a red marble. Okay. Question B from this same information says, how could we use this information below to find out about how many times we would draw a blue marble if we drew a marble out 50 times in total? All right, well, let's think about this a little bit. I'm going to make there just a little bit more space on this page. And we know that the probability is the times we draw. In this case, we're talking about drawing a blue marble. So draw blue over the total draws. So in this case, we can actually set up a proportion box because we know this is a proportional relationship. So we can use this information by saying, well, I drew blue 448 times out of 1,000 total draws. So it's asking how many times will I draw a blue. So I'm going to put my X right there over 50 times in total. So instead of having 1,000 draws, what if my draws was 50? Okay, well, before we even start, let's just notice a couple things. For instance, 448 is pretty close to half of 1,000. Half of 1,000 is 500. So it should be about the same. I should have about half of my draws be blue if I draw 50 times. So it should be somewhere around 25 draws. I hope that makes sense. And if it doesn't, I want you to stop the video right now and ask a question. So let's actually do the math. Well, I know that 1,000 divided by 20 gives me 50. And think about that. 5 times 2 is 10. I add those two zeros, I get back to 1,000 if you're having trouble. So that means in order to get from 448 to my variable x, I can also divide the top by 20. All right, well, going out to the side here and actually doing that math, I get 448 divided by 20. Okay, well, 20 won't go into 4, but it will go into 44 2 times. So then I get 40. I do my subtraction. I'm left with 4. I bring down my 8. 20 will go into 48 another 2 times. I'm left with 40. I subtract, left with 8. I add my decimal point and a 0. Extend this line a little bit. And then I bring down this 0. And 20 will go into 80 4 times. So that means my x is 22.4, which means that we would draw a blue marble about, let's estimate, we would draw a blue marble about 22 times out of 50 draws. And remember before when we estimated, we said that 448 was about half, a little bit less than half of 1,000. And we also estimated, we said that it should be a little bit less than half of 50. And 22 is a little bit less than half of 50. So that checks out. We passed kind of the smell test, as we like to call it. All right, let's move on to our next example. Okay, our next example here, we have different modes of transportation and then the number of students that use that mode of transportation. First of all, it says use the table to tell how much more likely it is for a student to walk to school than bike. Okay, well, just looking at this chart, it's actually the most number of students walk. More students walk than any other mode of transportation. So we need to find out how much more likely. So this is more likely, that's talking about probability. Well, I know that probability, the probability of walkers is the total number that walk. So we have total number of walkers over total students. Okay, well, I can fill in easily the top part of this fraction. So 394 walkers. And let's just go ahead and we could add them up here. 8, 5 is 13. That would be 17 and 20. Carry the 2. 2 and 4 is 6. Plus 5 is 11. Plus 9 is 20. Carry the 2. 2, 4, 6, 9, 10. So we have 1,000 students total. Okay? So that means there's 1,000 students. And really similarly to what we did before, remember how we just moved that decimal place over because we know that a percent is out of 100? So I can do the same thing. So that means that there are 39.4% of students that walk. I'm also going to find the percent of students that bike, and I find that by saying my bikers over my total students, and that is 103 over 1,000. And just like we did up here, remember that a percent is always out of 100. So in order to get 100, I move that decimal place over once. I move this decimal place over once. So here, my bikers is 10.3%. Okay? Now, the question though asks me, it says how much more likely is it for a student to walk to school than to bike? So here I have my two percentages. So to find out how much more likely it is, I actually need to subtract that. I'm going to move this down so we have just a little bit more room. All right, so how much more likely is it? Well, to get that, I say the number that the percentage that walks minus the percentage that bikes. And that, once I drop that down, is 29.1%. So that means it is 29.1% more likely for you to walk than bike. And I'm really sorry if you guys can hear my dogs in the background. They're kind of playing right now. All right, let's go on to our last example for today. Okay, so here, this last example says, if De Zavala students are just as likely to walk, bike, take a car, or ride the bus to school, out of our 825 students, how many can we expect to walk home? All right, well, we know that it's just as likely for our De Zavala students to walk, bike, take a car, or ride the bus home as this school, whatever school that is. So we also know that this is a proportional relationship. So we can set up a proportion box to solve this, to find out the number of students we expect to walk home. So that would be the number of walkers over the total. So we know from up here that the number of walkers from this other school, 394 out of 1,000, well, we want to know how many walk home, how many walk out of 825 students total. So now all we really have to do is set up this proportion box. And remember, I always want you to set up an equation. So we're going to start here by cross multiplying. So we get 394 times 825 equals 1,000 times x. Then when we do this math, I'm going to let you guys do this on your own. Make sure you have the workout here. So go ahead and pause it while you do this work. Okay. So now you should have gotten 325,050 equals 1,000x. And then we know to isolate the x, we're going to divide. We're going to do opposite operations and divide each side by 1,000. So 1,000 divided by 1,000, we're left with 1x. And here I can always move my decimal places over. So here I'm going to say I move it once here, I'll move it once on the top, move it once on the bottom, move once on the top, once on the bottom, once on the top. So that means that I am finally left with 325.05. So I could estimate that about 325 students walk home from De Zavala. All right, and that concludes our notes for today. We're going to do some practice with using experimental probability to make predictions and decisions. Hope you enjoyed watching this video, and let's get ready to work.